Hi, my name is Pramod Center at the UPA. I'm a PhD student in condensed matter theory here at the U of A. I'm also the current president of the Graduate Physics Student Association, also known as the GPSA. So I'm going to tell you a little bit about the graduate student experience here in the Department of Physics, how the GPSA fits into that picture before I hand it over to some of my friends and fellow executives of the GPSA for them to talk about the more fine-grained details of doing research within their own specific research areas. So, the Department of Physics is home to about 150 graduate students working on a diverse array of projects. Now, these projects can be grouped into a few different research areas. So you have geophysics, particle physics, space physics, plasma physics, astrophysics, condensed matter physics, which is dear to my heart, and probably the newest and fastest growing research area in the department is biophysics, which has been really ramping up over the last couple of years. As I said before, we'll get into the specifics of these areas a little later on in the video. Right now, I want to tell you a little bit more about the best opportunity for graduate students to interact with each other and get to know the research done outside their own area, which is the GPSA Symposium. So the symposium is a multi-day annual celebration of graduate student research done by graduate students, and it's organized by graduate students for graduate students. Now, this year was the 11th annual iteration of the GPSA Symposium, and in the before times, the symposium included 2 or 3 days of research presentations, posters, alumni talks about life and careers post-graduation. We get funding to fly in a colloquium speaker, who is usually a professor of physics in Canada, and they not only give a colloquium, but also a public lecture. This is usually a big event, draws in about 100 to 200 members of the public in Edmonton. It's also an opportunity for graduate students to flex their outreach muscles by doing physics demos for the public and also leading tours of lab spaces and the observatory that we have in the roof of the science building. Now, of course, this wasn't possible this year, so we had to organize a virtual symposium. This took place in January of this year, where students gave talks and posters in a virtual space, and we still had some great alumni and colloquium speakers, along with some workshops on how to make an academic website and how to prepare a CV. So as you can tell, the Department of Physics has quite a lot of activity involving graduate students. But of course, our main activity here is to do research. So let me hand it over now to some other grads to tell you about exactly that, doing research.
Hi, my name is Sneha Susan. I'm a second year PhD student with specialization in space physics.
Hey, my name is Michael Stallings, and I'm a physics PhD candidate at the University of Alberta, working on particle physics research at the Center for Particle Physics.
Hi there, my name is Zoe. I'm a second year PhD student in geophysics.
Hi there, my name is Max Yuan, and I am a second year PhD student here in the Department of Physics at the University of Alberta, specializing in condensed matter physics. So I'm going to tell you a little bit more about that and about my time here at the university.
We study the universe at all different scales, far and close by, stars and exoplanet, distant galaxies and the Milky Way where we live, Sun and all its planets including Earth, its fundamental processes, the process of charged particles and magnetic fields. We have Aurora Watch, which monitors the geomagnetic activity in real time and gives you the forecast in case if you have a chance of viewing the aurora. We also have an observatory in the campus. Right now, you can have a virtual tour if you are interested. We have a research group that focuses on various subdisciplines. We have a vibrant group here at the U of A. They enable the students to make the most of their time at the university and be better prepared for the next steps. They will provide opportunities to develop skills such as teamwork, independent learning, communication, leadership, and critical thinking. My research is in the area of space physics. The spectacular display of aurora are the processes that are associated with the different phases of a geomagnetic substorm. However, the events to which they are connected in the magnetosphere, especially those associated with the onset of expansion phase, are not well known. My research includes probing the magnetospheric substorm onset mechanism using satellite energetic particle data.
Condensed matter physics is the branch of physics which studies the macro and microscopic properties of matter. This can range from looking at a system of just a few atoms all the way up to a very large collection of many interacting atoms that can get quite complicated and whose behavior, oddly enough, is often quite different than the behavior of its individual components. Condensed matter physics also has an enormous amount of practical applications, from the development of better electronic devices and energy storage to the development of exotic materials, such as graphene shown here. I've also included a levitating superconductor and a quantum corral where you're actually able to see electron waves. The University of Alberta is actually quite strong in the area of condensed matter physics, with many esteemed faculty doing world-leading research. Some research areas are nanotechnology. The National Institute of Nanotechnology is actually on campus, as well as the NanoFab. An example of some of this research would be this image that was made several years ago on Canada's 150th anniversary by the Wolco Group. Each of these white dots is an individual atom, and that is the smallest maple leaf ever created, with that image being able to be placed across the width of a human hair about 10,000 times, and they look to continue to use this technology to make nano devices. There's also lots of very interesting low temperature physics on superconductivity and superfluidity. An example of this would be by the Davis lab recently, when they were able to measure the density of superfluid helium in a dilution fridge. The temperature of the dilution fridge, I believe, goes down to about 9 millikelvin, so it's one of the coldest spots in the universe. There's also lots of very exciting quantum information and quantum optics research, as well as molecular electronics and nanomagnetism, and several other research topics which I wish I had time to highlight. I'm personally a part of the Wolco Group, who specializes in nanotechnology, and we do what's been called atomic scale manufacturing. So I work with a machine similar to the one pictured here that has a very powerful scanning probe microscope. We can use this microscope to image things down to the atomic level, as well as manipulate these atoms to create things such as the maple leaf I showed in the previous slide, as well as atomic memory and atomic circuitry, with the goal eventually being to create smaller, faster, more efficient electronic devices at the nanoscale, because everything's better when it's nano.
Geophysics at the University of Alberta is pretty diverse. We have people studying geodynamics, not just of Earth, but of gaseous planets such as Jupiter. People are studying paleomagnetics, so essentially magnetic fields that are frozen in rocks and then moved, and then you can figure out how they've moved based on that and do plate reconstructions. People are also studying rock physics, so taking rock samples to the lab, doing experiments on them, as well as analyzing borehole data. I'm personally studying electromagnetics, so we'll talk about that in a bit. And then also people are studying seismic. And specifically applying machine learning to seismic data because they're very large data sets, as well as studying microseismics, so induced seismicity from fracking or other human sources. Okay, so I'm studying magnetotellurics, which uses naturally occurring electromagnetic fields in order to build a resistivity model of the subsurface. So then you're wondering, okay, what do you do with the resistivity of the ground? How does it help you? And so essentially what we're doing is we're trying to evaluate the geothermal potential of Alberta. And so Essentially how we do that is hot water conducts electricity better than cold water, and so that'll give you information about the thermal properties.
I'm interested in searches and phenomenology of new physics beyond the standard model. Particle physics research is active and vibrant at the University of Alberta on both the theoretical and the experimental fronts. There's also an active astroparticle community here. And I'd like to tell you a bit about these active fields of research happening here at the University of Alberta's Center for Particle Physics. Regarding experimental particle physics research, you could get involved in hands-on detector work or data analysis and simulations. And several faculty members at the University of Alberta are involved in collaborations at the Large Hadron Collider at CERN in Geneva. For example, there's the ATLAS experiment, a toroidal LHC apparatus, which is the largest general-purpose particle detector experiment at the LHC, famously known for their 2012 discovery of the Higgs boson. There's also the metal experiment, the monopole and exotics detector at the LHC. This is a dedicated experiment looking exclusively for highly ionizing particles as avatars of new physics beyond the standard model. These could be, for example, magnetic monopoles. In terms of astroparticle physics research, there are several faculty members involved in the IceCube Neutrino Observatory, shown here, which is recognized as a CERN experiment, and Pingu, the Precision IceCube Next-Gen upgrade. Faculty here are also deeply involved with numerous experiments located at SNO Lab. There's SNO Plus, another neutrino experiment, and several dark matter experiments such as Deep 3600, PICO, and NEWS-G, the new experiments with spheres gas. To facilitate all of this work, the U of A has many facilities. Mainly, there's the Advanced Machining Facility, the Low Background Counting Facility, and the Reduced Radon Clean Facility. And lastly, the theoreticians in the department working on particle physics are focused largely on performing precision quantum electrodynamics and quantum chromodynamics calculations for the next generation of experiments searching for new physics. Typically, these calculations are performed at next to leading order and beyond. Now, I would also like to tell you about the leading particle physics research facilities in Canada, one of which has already been mentioned, namely SNO Lab, as well as TRIUMPH. SNO Lab is the Sudbury Neutrino Observatory Lab, a world-class science facility located deep underground in the operational Vale Creighton nickel mine near Sudbury, Ontario, in Canada. And interestingly, SNO Lab is the world's deepest operational cleanroom facility. It's accessed through an active nickel mine, yet it maintains a Class 2000 cleanroom in the laboratory. What this means is that at a given moment, there's a maximum of 2,000 particles per centimeter cubed of inside air. There's also TRIUMPH. This is Canada's Particle Accelerator Center located on the campus of the University of British Columbia. And the heart of their facility is the world's biggest cyclotron, which is used to accelerate 1,000 trillion particles each second. Both are internationally regarded as leading particle physics research centers.
My favorite experience so far in grad school is definitely fieldwork this summer. So I spent essentially 2 weeks in a helicopter flying around a volcano, setting up equipment. So that was just north of Vancouver on Mount Meager, which you can Google, it's pretty cool. So the physics community at the University of Alberta is pretty active. We have different social events, different student groups that you can join, as well as lots of different technical aspects as well. So talks, the symposium, which is like a student-run conference.
When I think about my favorite experiences at the U of A during the past 18 months, many instances come to my mind. Being selected as the Astro Space Visit representative of GPSA was a moment of happiness. Talking to different students from different countries and different languages was a great experience. Another notable experience is the transition to online classes and labs during the pandemic. It didn't affect me a lot because of the great support that was provided by the professors and the staff for the physics department. I take this moment to say huge thanks to them.
Overall, the level of research here is really top-notch. I recall when I first arrived, especially being an experimentalist from a smaller university, I was instantly impressed with the quality of the equipment that I have access to. It's quite fantastic. Beyond that, there's also lots going on in the department. For example, the recent symposium and weekly colloquiums are great opportunities to not only learn more about what's going on in your field, but be exposed to other fields of physics you might not be as familiar with. There's also lots of fun social activities. For example, last year the GPSA put on a curling day, which was just a great time to blow off some steam with colleagues. So overall, I think the community here is quite welcoming and open, and it's been a great choice so far for grad school.
As an advice to the incoming graduate students, you have come to the best place to learn. Try talking with different students and connect with them. Express your concerns to your supervisor and to the professors.
My advice for new grad students, definitely get involved, meet some people. If you need help, definitely ask for it. You're not in this alone.